Hi, today I'm going to do 2-2 rates of change. The math practices that we are going to go over are identify information from multiple representations and describe the characteristics of a function. So we started rate of change with 2-1. We talked about it, but it's synonymous with slope. Slope is a linear term, we use with lines. So rate of change, we say that mostly with polynomials or other functions. So positive rate of change indicates the function has a positive slope. The function is increasing. A negative rate of change indicates it has a negative slope. The function is decreasing. Rate of change at a point. We define rate of change at a point as the rate at which the output values would change if the input values would change at that point. In calc, we're going to talk about instantaneous rate of change, but now we're just talking about rate of change. So the output values would change if the input values were to change at that point. Okay? So if we put in a value, there's going to be a change in the output, or the y, and that's going to be the rate that it changes, rate of change. If you're unable to find the rate of change of a function at a point, but we need to determine rate of change of a given point as positive, negative, or 0. So you know that from slopes, right? Positive, negative, or 0. When considering rates of change at a given point, it may be helpful to think of a graph as a roller coaster. I did tell you to think of the roller coaster when we're increasing and decreasing. So if you're going up, reading left to right, it's a positive rate of change, negative or 0, not changing at all. At the instant, the point when you're at the top of the peak or the bottom of the valley, you are not moving up or down. A single point, you're changing between going up and going down. At these points, the rate of change is neither positive or negative, so it is 0. So here's an example. T1 is a positive rate of change because it's going up. T2 is 0. And T3 is negative because it is going down. Fun fact, fastest roller coaster in the world, built in 2010, reaches a speed of 149.1 miles an hour. For comparison, the Indy 500 was only 143.6 miles per hour. So that's a pretty fast rate. All right, so we spoke briefly in 2-1 about the difference with the rate of change and the function. So this is the graph of f. This shows the graph of f on the xy plane with 3 points, A, B, and C. Order the rates from least to greatest. So this is pretty level, so this rate is 0. This is on the downslope, B is negative, A is going up, so it is positive. So in order, it's going to be least is B, and then C, and then A. The figure shows a function g of the following points which would change the least. So B is pretty steep, A is not as steep, C is going down but not as steep as D. So changing the least, I would say, is A. I'm going to get my folder just to make sure, because A is not steep at all. Well, as steep as the others. Oh, I was wrong. I had it right in class and I'm wrong here. It is not A, it is D, because it is negative and it's the most steep negative. Oh, which is it the least? Not the change the least, which is the rate of change the least. That makes sense because this is negative, but it's more steep than C. So C is also negative, but it's not as steep. B is positive, and A looks about 0 or a small positive. So this is the least because it's the most negative. Another important concept that we'll have is the average rate of change, and we'll get into that today. Okay, second page. So here's the average rate of change. The average rate of change, you find 2 points and you're finding the slope between those 2 points. Now, it's just an average, so you're in a polynomial, you're not using the exact what's going over the polynomial, you're just taking the difference of those 2 points. Remember, slope is y2 minus y1 over x2 minus x1. It doesn't matter which point you do first, as long as they're together like this, and these are together like this, and they're both subtraction. So looking at this polynomial, which interval is the average rate of change the greatest? So the greatest would be the most positive. So first we're going to look between 2 and 3. So 2 to 3, well, that looks like 0. So that's probably not the greatest, but we'll see. My line looks a little slanted, but it really is 0. Between 3 and 5 is right here to right here. Now this line is negative. So this is negative, this one's 0. 5 to 7 is right there, 7 is right here. That is a positive rate of change. And then 7 to 8, 7 is right here and 8 is right here. Again, it's going down, so that's a negative. So the only one that's a positive rate of change, which would be the greatest, is 5 to 7. Okay, these are the average rate of change because we're just finding 2 points. Notice here we're going down and then up, so the difference is 0. Example 4. The graph f of x always has a negative rate of change. Which are the following, which would be a good one for it? Good model. Which of the following definitions for x and y would best model the function always have a negative rate of change? So the number of age of a young child and the height of the young child. So at age, as age goes up, our height goes up. So that's going to be a positive. That's not a negative rate of change. Total number of points scored at a basketball game, the time remaining. So as that one goes up, the remaining goes down. Or I could write it like that. So it'd be a positive over a negative, which would be a negative. But let's check the others to make sure. The time in seconds once a ball is thrown in the air, and the height. So time goes on and the height goes on. So positive, that one's also a positive. So these are positive. The radius in meters in a circle and the area. Well, that one's a little different because radius, area is pi r squared, which is not positive or negative. Well, I guess the r squared is positive, but it is not. So the answer is B, time remaining, because time remaining is going down. That's the negative part, and a positive divided by a negative is a negative. The function here, which of the following are true? So you could graph it from negative 10 to 10, or I will show you what it looks like, just so you know. So it passes about right here. 1, 2, 3, 4. This is about 2.47, the vertex, 8.3. So this is 8.3. And so it goes, there's a 0 there, and then there's a 0 at about 6. Okay. So positive rate of change from negative 10 to 8 point. So that's going across. No, this is a positive rate of change because it's going up. But over here it's negative, so it's definitely not that because we're going from negative 10 to 8.4. It's way over here. It's going up and down. Positive rate of change between negative 0.6 and 5.6. So 5.6 is here. Again, we're starting down, going up. Nope. Negative rate of change from negative 10 to 2.4. Well, yeah, this is a lot smaller, but it's not a negative rate of change. I'm sorry, my bad, because it's increasing right there. It's actually getting higher, so it's not that one. Negative rate of change from 2.4 to 10. So that's this part, and there it is going down. So it is D. Okay? Because this is a positive slope, this one's a negative slope. Looking at these, remember that year time is always X. That's your independent variable, that's your input. Your Y is the other variable. Usually in tables, X is first, or if you have a table like this, it's usually XY. But the table gives the life expectancy of you as females born in a given year. Which of the following intervals is the rate of change the greatest? So we have to find all the rate of change. So the first one's from 1800 to 1850. So we have 2 points. So our time is the X, so we're finding the slope really, 1800. And then I get, since I started with 1850, I'm going to do 4610 minus 41.24. Divide those. 1850 to 1900. Again, the bottom is 50, but if I do positive 50, it'll be 1900 minus 1850, so I had to do 53.63 minus 4610. And then 1900 to 1950, so 1950 minus 1900, so started with 1950. And then the last is 1950 to 2000, 50 years, starting with 2000, 81.83 minus 70.65. I guess I only did the first one in class, 0.0972. I will do the other ones now. I'm sorry I don't have them done. Okay, 4610 minus 41.24, enter, divided by 50. That's a 0.0972, 53.63 minus 46.1 divided by 50. That is 0.1506, 70.65. I hope I'm typing in them correctly because I'm doing it pretty fast. 53.63, enter, divided by 50 is 0.3404. So we're looking for the greatest. And 81.83 minus 70.65 divided by, oops. You have to hit enter unless you do the vertical division. 0.22. So the greatest one is C. Okay, 34.04. All right, let me know if you have any questions. Thanks.